All right, let's look at these different examples using that formula for expected value and standard deviation. So this scenario here, we're going to come up with the probability model. So you draw a card from a deck. If you get a red card, you win nothing. If you get a spade, you win $5. And for any club, you win $10. So we want to create a probability model for the amount that we win. So that's what X is going to represent. It's going to be the amount of money we win. And then what we'll have is the probability of winning each of those amounts. So in terms of possible winnings, well, we can win nothing, or we can win $5, or we can win $10. Getting a red card sets half of the deck. So our deck of cards is made up of black cards and red cards. So in terms of probability of drawing a red card, that's a 50% chance. Then if you get a spade, if we think about the probability of drawing a spade, it makes up 1/4 of the deck. There's the hearts, diamonds, spades, clubs. So spades is 1/4 of the deck, so that's a 0.25. So 25% chance of drawing a spade and getting those $5. Same thing for drawing a club, 25% chance there. So we end up with our probability model. Just make sure, a common mistake is to put words here. So if I had written like red, spade, club, but that won't work. We need numbers for X. So just make sure you think about, and often they'll describe what they want you to describe with the model, and that'll give you your values for X. Then also make sure, we want to make sure that adds up to 1 so that we're covering the whole probability model. So expected value, we take each X value times its probability and add them up. So 0 times 0.5 plus 5 times 0.25 plus 10 times 0.25, which will be a 3.75. And then for standard deviation, we're going to have a big square root. Then you take your first X value of 0 minus that expected value squared times its probability plus, and then you move on to the next X value minus the mean squared times its probability plus the next X value minus the mean squared times its probability, and throwing that into the calculator, that should give you a 4.15. So this mean and standard deviation, what that's telling us is we expect to win $3.75, and on average that deviates by $4.15. And this might happen sometimes where it feels kind of expect this much, and on average it can change by a larger value. And why that feels weird is because if we subtract $4.15 from $3.75, it's like we'd get a negative number out. Really, when this happens, we end up with kind of a small expected value and large standard deviation. What it's saying is that 0 is a likely outcome. 0 is highly likely here. We expect that half the time. So you end up with kind of this small expected value, large standard deviation. That's what's really being said there. 0 is a likely occurrence. Let's look at this next model here where they give us part of the model for the number of repair calls and their probabilities. So here we can see they either expect, or they get 0, 1, 2, or 3 repair calls in an hour. And then we have the probabilities, but we're missing this one right here. Again, if we think about what we have so far, we've covered 80% here. If you add that 0.1, 0.3, 0.4, all of that together makes 0.8, which means right here, we have our 100%, but we take out the 0.8 that's already been covered. This is going to be a 0.2, 20% chance right here. So in filling in the tables, just use that 100% to kind of distribute them. Expected number of calls, we take each of the x values times their probability, and the 3 times 0.2, and that should give us a 1.7. And then for standard deviation, again, big square root symbol, and then we take each of the x values minus the mean squared times its probability. I'm just going to write this a little shorter until we'd end up with 3 minus the mean squared times its probability, and that's going to be a 0.9. So this would mean the shop would expect 1.7 calls per hour, and on average that deviates by 0.9 calls. And that's our expected value and standard deviation for discrete random variables.